Hey, so this is Andrew, and we are group AH7. We're just responding to the experimental analysis for shortest path. Um, so yeah, it's actually good that you brought this up. We kind of revisited our experimental data and answered a lot of the original questions we kind of glossed over. So if we look at the kind of runtime analysis we did for worst case, you can see we really think that tuple sort and dynamic programming will be the best way or best way to solve this. Will be the fastest, and as you can see with our runtime analysis in the experiment, this is from our experimental data. You can look and see that, wait a second, we're seeing that our generative seam finder tuple sort is actually the worst runtime here. And we kind of scratch our heads, wonder why our predictions don't match our actual runtime, experimental runtime. So, you know, to sum up, what we found was that the generative seam finder using Dijkstra's has a better runtime than generative seam finder tuplesort, and adjacency-less seam finder uh, using tuplesort has a better runtime than Dijkstra's. So the first one is kind of not what we expected. Second one is more what we expected, and we kind of wonder why. And this really goes back to the idea of how we're implementing these algorithms, and the first in generative seam finder, we're generating the pixels and edges are only created when called, when the pixel.neighbors is called. So, and then they're not stored as well. So if we're using Dijkstra's and let's say if we have, going from source to sink, the last nodes, right? We want to kind of traverse the graph, so we're calling neighbors as we go and then finding our shortest path. That's great. And that would allow us to have, just go through each one and not have to worry about what happened before or store all those values, which is what we're not doing. But if we look at, tuple sort is really just a reverse depth first search, and that really relies on traversing the graph and then going back over it. So because we're reversing, and that kind of is really detrimental to the runtime here because we have a graph that's not being stored. Those values, since those values and pixels and edges are not being stored, we're kind of doing the whole generative scene finder again, right? So we're calling pixel.neighbors again and again and again, even though we've done it before. So that's why kind of Dexter is quicker in that sense for generative scene finder. Now, conversely, for adjacency scene finder, we found that tuplesort is actually better than Dexter. So this goes along with our predictions, and we're saying that, hey, okay, the values are being generated, but they're being stored. So there's not an extra cost to go back over them because we've already explored all of the values. We got the pixels and edges. They're already created, so there's no extra cost, and that's why tuplesort here is a better runtime than Dijkstra's because that call ahead doesn't have an extra cost. Anyway, I think that really wraps up in our experimental analysis for this part, and thank you for bringing it to our attention.